state change detection. It's taken from the example files in Arduino, but I've modified it quite a bit, so it doesn't look exactly the same. You can look at the original if you want, but this is modified. So you can see this is a good practice for open source code. It says modified November 2020, Doug Witten, which is the best practice. Okay, so this code has a button pin. We looked at the circuit already. So the button is inputting on pin 2, and then pin 13 is lighting up the LED. So it's really simple. It's just a toggle. You turn on, turn off. So this word const is constant. It means that that variable, which is an integer button pin, it's never going to change. So it's kind of locking the number 2 into that variable. You cannot change that variable, which is good because it's hardware. You don't want it to mess up by changing the number of that variable. And that's all it does. It would work just fine if you just say int button pin 2, but it wouldn't be as strong. It would be unbreakable if you make it a constant. So button state equals 0, last button state equals 0. So these are being used to monitor what state is the button. So a bit of explanation, like what do I mean by state? So in hardware programming and engineering and software, the idea of state means that in this case, one button is going to change state. It's got 2 states, on and off. And then in software, we can represent that in different ways as a Boolean and say true and false, true if it's on, false if it's off, or 0 and 1, 0 if it's off, 1 if it's on. So just think of state as a really simple example of state would be a traffic light. You're driving up to a traffic light and it's got 3 states, red light on, green light on, yellow light on. And each of those colors will tell the driver what to do. So obviously you drive up to an intersection, and if the red light's on, you stop, and if the green light's on, you go. And then if the yellow light's on, you decide what you want to do. There could be all kinds of things you can do there. But basically it's got 3 states. And so our button has 2 states. So in the setup, we've got the button pin is set as an input because we're pushing the button, and it's now going to push 5 volts of electricity into the button pin. So it's an input. And then the LED pin, when it gets a signal, it's going to turn on the LED by outputting 5 volts of power. And in the loop, we can keep track of the state by saying, okay, button state equals digital read button pin. So we're reading the value of the button pin, okay? And the state, that button state is going to change. Whenever the user pushes it, it's going to change from 0 to 1. So in the comments here, I've written out an explanation of what's going on. And then to see in the serial monitor what's going on, you do a serial.println, the name of the variable button pin, or you could also do serial.println digital read 2 would give you the same output. It's basically where we want to read what state that button's in the loop as the program's running continually, because the user is going to push it randomly. We don't know when the user is going to push the button, so we're reading constantly what the state of the button is. And then the program can do different things when the button is pushed. So in this case, it's going to compare the button state to the previous state. So let's say the previous state is off and the current state is on. Okay, and so now we're getting into logic. And logic is, in programming, you have to really figure out logic before you write the code. Writing logic statements is always difficult, I find, anyway. So if the button state is equal to high, meaning high means that it's on and there's 5 volts of power there. And notice that the logic operator here is 2 equal signs. It won't work the same way if you have 1 equal sign, because that means that you would be putting the value of high into button state, and that's not what we want to do. We want to look at the equivalence, like, is button state high? So if it is, we're going to write the LED pin to be high, meaning we're going to turn on the LED. Else, if it's low, then we're going to make the LED go off. So the first one is just This program is just what you're used to. You push the button, the electricity goes on, you release the button, the electricity goes off. And then the last thing we do here is there's a little delay, and you have to delay programs quite often because otherwise the electricity is going faster than the program can read. And so you want to slow it down a bit so that they get in sync. And if you're creating a certain functionality with a button, you have to test it, and you might have to increase or decrease the delay to make it work for the actual button. Like the button I'm using on this one, it's actually pretty clunky. It actually takes a little while to really push it and release it. And then the last thing we do is we update the value of last button state with button state. And so we're continually, every time this code cycles through 60 times a second or 30 times a second or however fast, it's taking the button state and putting it into the last button state. So when that button state changes, it triggers an event.